Greetings! In this homework problem, we're going to review variance and standard deviation. So the variance is roughly the average squared distance away from the mean. The standard deviation is the square root of the variance. The standard deviation is useful when considering how close the data are to the mean. A very good way of thinking about the standard deviation, it is as the average distance that all of your data points fall away from the mean. What that says is that if you took all of your data points and you calculated the distance between the mean and those data points, and then you averaged all of those distances, all those individual distances, you would roughly be calculating the standard deviation. So the standard deviation, its main tool in life, what it does is it describes the variability. So focus on the conceptual meaning of the standard deviation as a descriptor of variability. Don't focus on the formulas. We have a calculator that will do the formula for us. Usually 70% of the data are going to be within one standard deviation of the mean, and about 95% of the data will be within two standard deviations of the mean. That's a rough rule of thumb. We'll tighten that up as we go further through the course. Key idea is that the larger the standard deviation is, the more variability there is in your data. So in this homework problem, they ask us which of the below data sets has the lowest standard deviation. And they say you do not need to calculate the exact standard deviation to answer this question. So how would we go about doing that? Well, let's think about this using a number line, okay? So if we came in with our first data set here and we said, okay, here's 0 on this number line, and then this number line goes all the way out to 200. So this number down here is at 0, this number up here is at 200, and it looks like our middle number, or our mean, is at 100 here, okay? Now it looks like we've got what, 1, 2, 3 zeros, and we've got 100, and then we've got what, 1, 2, 3 200s, okay? So it seems that we've got a bunch of weight on one end, a bunch of weight at the other end, so our variability is pretty big here. We're pretty spread out. Let's compare that to the second data set here, where if we were to mark those on the number line, we've got what? We've got 0, 1, 2, 3, putting dots above them, and then the 4, and the 5, and the 6, okay? Data not to scale here, obviously that's not 6 units towards the 100, but we'll just roll with this, okay? So it'll hopefully make sense. And we notice that they're definitely a much smaller distance overall if you go from 0 to 6 than there was from 0 to 200. So far this is our leader in the quest for being the smallest standard deviation. Okay, let's take a look at this data set. So same idea, we'll put them on a number line here, and we go, okay, here's 0, and then here's 1. Those are the data points stacked above them. And then here's 3. Oh, and then we've got what? We've got 3 of them stacked on top of the 3. And then here's 4. By the way, here was 2, right? And then here's 5. Got a data point there. And then here's 6. We've got a data point there, okay? So now notice you would say, all right, well, Mike, the distance between 0 and the 6 is the same as both of these, but this one has more 3s in it. So it has less variability than the previous data set. One way of thinking about that is to say we took these numbers and put them in a hat, put them on slips of paper and stuck them in a hat, and we took these, wrote them on a slip of paper, each individual ones, and stuck them in a hat. You've got a much better chance in this data set of pulling a 3 out of that hat than you did over here in this one. It's just more likely that that's going to happen. So far this is our big winner in terms of who's got the smallest standard deviation, and this one hopefully is pretty obvious. Again, if we go, here's 0, I mean, I'm going to be off of my screen if I try to get out to 1,000, even close to the same scale that I'm working before. So this one's going to have the largest standard deviation of all of them. So it appears that this one right here would be the one we would select. Okay, now that hopefully wasn't too horrible to figure out, but I would like to verify our result there, and as a way of review, show you how to take your calculator and calculate a standard deviation. So let's go through these 4 data sets and let's calculate the standard deviations for all 4 of those using our calculator. So to do that, let's go get our calculator up here. Let me go ahead and clear off our annotation so we can see our calculator. We're going to have to enter in those data sets into the calculator, okay? So let's go ahead, I'm going to go ahead, if you don't mind, I'm going to do them in reverse order. We'll go up this way with them, or maybe not. The way I've got them written down is on my page. I'm going to try and remember the order that we got it, but we'll see how it goes here, okay? All right, so let's do actually the last one first. We're going to put in a 0, a 25, oh, my bad, excuse me. Let me show you how I got here. So press on your Stat key on your calculator, then go to option number 1, which is Edit. If there happens to be any data sets or data points in L1, which is the data list I'd like to put my numbers into, highlight L1 by getting on top of it, press the clear key, and then hit the down arrow, and that will clear out all of the data in your data set. Do not use delete for clearing a list. Use clear. You're trying to clear a list, okay? All right, now let's go ahead and put in our numbers. So let's put in 0, 25, 50, 100, 125, 150, and 1000. Okay, now I'd like to calculate the standard deviation of all of those data points. To do that, we're going to press our stat key. We're going to go to calc, and we're going to run a 1var stats. So now, excuse me, depending on which model of, sorry about that, which model of the TI-83 384 you have, you may get a slightly different menu here, okay? So if you're on an older one, it'll just say 1var stats. The default list is L1. So you don't really need to do anything if you're on an old dog calculator if you stuck your data into L1. If you stuck it anywhere else, then you're going to have to tell it the list of where it resides. Ignore the freak. Do not touch the freak right now. Press and enter. And what we have are the following numbers. Okay, now we're going to assume in this data set, I'm going to turn the annotation back on for a second here. We're going to assume in our data set that these were all samples. So if these were sample data, then we're going to want to select this standard deviation. This is the sample standard deviation. This one down here is also the standard deviation, but that's not a sample. This one's from a population. So if you had done a census, in other words, you collected every possible data point that was available, then you would use that standard deviation. The difference between them is that when you divide out by the number of data points in S of x, you divide by n minus 1. And in the population data set, you divide by n. And notice I'm going to use a capital N here to indicate that I have the entire data set, okay? That's not a sample, that's the entire population. Okay, as I said, here, we're going to assume for the moment, let's assume that these were sample data. So our first standard deviation appears to be 353.764. Let's go back to our data here. Okay, so this one would be, for this data set down here, let me get a new page of annotation here. Give me just a second. Sorry guys, I'm learning a new tool here to do my page annotations with. So I'm still figuring this all out. Okay, so this may be a little rough, apologize for that, but we'll get it. Okay, so on this new page, let's turn on the pencil. There we go. Okay, so back to the calculator here. So that was 353.764. That's a 3, they're honest. 764. Okay, so that's the first standard deviation. Okay, let's do just a couple more of these and I think we'll call it good. All right. Okay, so let's go back to the previous page of annotation here. Let's go ahead and clear that one out. And then let's go back and get ourselves the new data set in there. So I'm going to go to Stat. Let's go to Edit. And let's go ahead and clear that data set by getting on top of L1. And let's press a clear. And then hit the down arrow to actually get it to clear it. And let's go ahead and take a look at the smallest one. That was the largest standard deviation. Let's go take a look at the one that had the smallest standard deviation. So that would have been 0, 1, 3, 3, 3. You got to enter all of those threes, okay? And then we're going to put in a 5, and then we're going to put in a 6. Okay. So again, to calculate the standard deviation here, we'll press Stat. We'll go to Calc. We'll go to 1var Stats. And again, the default is L1. If you've entered your data in L1, you do not need to tell it the list. If it's any different list than that, you will have to change that. Press Calculate. And notice that our standard deviation, again, we're going to assume that we are working with a sample standard deviation, so we're going to use S sub x here. Let's assume that this was sample data. So here the standard deviation is quite a bit smaller. It's 2.082. Okay. So let's go back to our slide here. And this one turned out to be, what was it again? We said it was, switch back to the calculator for just a moment. It's 2.082. And so what we can see is that this has a much larger standard deviation, which we already knew because of our picture we did earlier, than this one, which tells us this one has a much smaller standard deviation. Okay, so just as way of review or learning, depending on which way we're doing this for you, I would encourage you to calculate the exact standard deviations of those last two and check to see indeed that they do end up being larger than this number and that this one actually is the smallest standard deviation. Okay, hope you found that useful. Keep on working. Thank you again for all the hard work and your attentiveness.